And this is now section 4.2, which is trig functions using the unit circle. So the unit circle has a radius of 1, and this is the important part here to note, that sine theta is the y value of each point, and cosine theta is the x value of each point. So if I wanted to find trig functions using the xy points on the unit circle, my sine, like I said, is y, and cosine is x. Tangent is y divided by x. And we have cosecant, secant, and cotangent, which we use less often, but you still need to know how to find them. And as soon as you find the first three, sine, cosine, and tangent, we just flip those three to get the reciprocals. So cosecant is 1 over y, secant is 1 over x, and cotangent is x over y. Here's a copy of the unit circle that you will be using throughout the quarter, throughout the whole semester actually. It gives you all the xy values of smaller angles, the ones that you're going to be using more often. So just know how to use that. And so this would be the x value, that would be the cosine, and the square root of 3 over 2 would be the y value or sine of pi over 3. So just make sure that you're understanding how to read the unit circle. So using that unit circle then, we want to find all 6 trig functions at the real number pi over 6. So what I want to do is find the point, the xy point that goes along with pi over 6, and then we can do this together. So the xy is square root of 3 over 2, 1/2. So now sine is the y value, which is 1/2. Cosine is the square root of 3 over 2. And tangent is y over x. So let's go through and divide this. I would multiply by the reciprocal of the square root of 3 over 2. So I would have 1/2 times 2 over the square root of 3, which is 1 over the square root of 3, which we cannot leave it like that. We have to multiply by the square root of 3 over 3. Or square root of 3 over the square root of 3, sorry. And our answer would be the square root of 3 over 3. You don't always have to show that much work. As long as you start understanding the concept of multiplying by the reciprocal, you can start to see that in your head, but just that first time I wanted to show you all the steps. Cosecant is the reciprocal of sine, which would be 2 over 1. Secant is the reciprocal of cosine. Flip it over, 2 over the square root of 3. Can't leave it like that. I have to multiply by the square root of 3 over the square root of 3. And our answer is 2 times the square root of 3 over 3. Cotangent is the reciprocal of tangent. What I would do is actually I would start, before I rationalize it, I would take that and flip it over. So it would just be the square root of 3 over 1, which is the square root of 3. You can also, if you don't recognize that or see where you would flip it over at what point in your work, then you would just take the x over y, so it would be the square root of 3 over 2 divided by 1/2, or times 2 over 1. And it would simplify pretty quickly. Okay, 5 pi over 4. The point is negative square root of 2 over 2 and negative square root of 2 over 2. So sine is my y value. Cosine is my x value. Tangent is y over x. And it's easy to recognize because these are the same value that your tangent is going to be 1. So my reciprocal functions, cosecant, I would flip it over. I can't leave it like that, so I have to multiply by the square root of 2 over the square root of 2. And this would end up being negative 2 square root of 2 over 2. 2's cancel. Just get negative square root of 2. Secant, I don't need to go through all that work again because the cosine was the same. So it's negative square root of 2. And cotangent is also 1. At pi, our point is negative 1, 0. So sine is 0. Cosine is negative 1. Tangent is y over x. So it's 0. Cosecant is the reciprocal, so 1 over sine, which doesn't exist. Secant is 1 over cosine, which is still negative 1. And cotangent, I could flip it from my work right here. So it would be negative 1 over 0, which also does not exist, undefined. Okay, now we're going to talk quickly about the period of the sine and cosine function. So we notice that the unit circle has 2 pi for its entire revolution. So if I started to go more than that, the values would just start repeating themselves. So 2 pi is going to be the period. That's when they start to repeat themselves. Up here is mostly a little complicated explanation of what I just said. This is cyclic. It repeats itself, so knowing that, we can find the cosine function of something bigger than 2 pi and just refer back to the unit circle for something that is a coterminal angle of that. So if I evaluate sine of 13 pi over 6 using its period as an aid, what I'm saying is that I want to figure out a coterminal angle using the period as an aid. So recognizing that every 2 pi it repeats itself. So I can subtract 2 pi from 13 pi over 6 to find an angle that's on the unit circle, and then I can just use that. So this is pi over 6. So what I can actually do is just evaluate the sine of pi over 6, and it'll be the same thing as sine of 13 pi over 6. And this is 1/2. From the unit circle, the y value at pi over 6 is 1/2. Okay, the last thing is just talking about even and odd functions. Cosine of negative t and secant of negative t, these two are even functions, meaning that the cosine of negative t is going to be the same thing as just cosine of t and secant of t. And the other 4 are all odd. So if I'm trying to find the sine of negative t, it would be negative sine t. All these would be the same. So just a quick little example down here. I know you don't have this in your notes, but just to explain my point again. If I want to find cosine of negative pi over 4, I recognize that cosine is an even function. So what I could just do is look up the cosine of pi over 4, which is on the unit circle, which would be an easy thing to find. The square root of 2 over 2. However, if I'm trying to find the tangent of that same angle, negative pi over 4, because tangent is odd, then that would be the same thing as negative tangent of pi over 4. So the tangent of pi over 4 is 1, which means negative tangent of pi over 4 is negative 1. Okay, so that's what I mean by even and odd functions. And that is section 2.